Hi everybody. Well, stegosaurs are a group of armoured dinosaurs that are known from the Middle Jurassic and primarily Upper Jurassic deposits worldwide. I think they're one of the most easily recognisable dinosaurs, but despite their iconic status, they're actually surprisingly rare as fossils, and thus much remains to be found out about their paleoecology and their evolution. Now, the most famous member of the clade is Stegosaurus, of course, from the western US. And there are currently two recognized species of Stegosaurus. Stegosaurus stenops, which is the best known species. It's represented by several more or less complete individuals and a large amount of fragmentary material, some of which is shown here. And I don't know how this works. There we go. And Stegosaurus musi. So this is a much less well-known taxon. It's represented by the holotype, in the literature at least. There are three partial specimens, three more or less complete specimens in a private museum in Switzerland. And there's a number of other specimens that have been reported, but they currently reside with a commercial collector. So we don't really know much about those. So for all intents and purposes, we know this species really only from the holotype individual. Now, in the summer of 2015, my co-authors at the Museum of the Rockies found a new specimen of Stegosaurus from some of the most northerly outcrops of the Morrison Formation, right the way up here in Montana. So here's Montana up here on the Canadian border. This is Bozeman, where the Museum of the Rockies are, and the quarry is just right here. It's called the Livingston Quarry, and this is it. There's been a couple of other dinosaurs known from this site. There's a sauropod from, I think it was from the lower quarry, which is this quarry here. And then there's also an Allosaurus specimen that's come from this slightly higher up level, which is just a long strike from this quarry. And this is about the same location as the Stegosaur was found. It's actually found a long strike from the location of the Allosaurus. Now, when I went to have a look at this specimen, it quickly became clear that this was a new specimen of Stegosaurus musi, this very rare species that we don't really know much about. So this is quite an interesting and important specimen, really. The specimen comprises a really nicely preserved skull. It's preserved in 5 separate blocks, and that's really nice because we can have a look around it and see the anatomy in a lot more detail than we would be able to otherwise if it was just in a single block. And here you're looking at a ventral view, so you're looking into the mouth or the palate of the stegosaur, and you can see that it has this beautifully preserved palate, and this is actually the best preserved palate of a stegosaur from anywhere in the world. So already this specimen is offering some new information that we didn't already have about stegosaurs. Now, you'll be extremely relieved to hear that I don't intend to describe you the anatomy of this animal in this talk. However, I'm just going to point out a couple of features that allowed me to identify it as Stegosaurus musi. This is the skull in lateral view, so you're looking at the side of the head, and it's got some vertebrae coming out the back. This is the axis, and you can see here that the axis is strongly upwardly concave. And this differs from the condition in Stegosaurus stenops. So this is vertebra from Sophie, which is the Natural History Museum's Stegosaurus specimen, which is referable to Stegosaurus stenops. And you can see that's got a flat ventral margin of the axis, and that's similar to other stegosaurs, such as this Middle Jurassic British form called Loricatosaurus. So that characteristic is a feature, an autapomorphy of Stegosaurus musi. Now, stegosaurs have really, really unique dorsal vertebrae. Their dorsal vertebrae are stretched and elongated. And one of the autapomorphies of Stegosaurus musi, when it was first described, was that it didn't have these stretched, typical stegosaurian vertebrae. And our new specimen has a dorsal neural arch preserved, a single dorsal neural arch, and it's not stretched. This is it. You can see here we don't have this elongated pedicle region between the top of the neural canal and the prezygohypophyses. However, when Paul and I were describing Sophie at the NHM, we noted that actually there's a range. This is not actually a really good characteristic, because there's a range of stretchedness as you move down the vertebral column, and we didn't know that before because Sophie's actually the only stegosaur in which we have a fully articulated vertebral column. So we found that the anterior dorsals of Sophie were not stretched at all, so this is one of them, and this doesn't have a stretched, elongated neural arch either. But what you can see here is that the prezygohypophyses, which are these features that allow the vertebrae to articulate together, face dorsally in Stegosaurus stenops, but they face, in our specimen here, they face sort of inwards towards each other. So the combination of not having a stretched neural arch and these pre-zygid apophyses that face towards each other is unique for Stegosaurus musi. So I'm fairly confident that this specimen is what I think it is. The specimen also comprises some appendicular material that's not brilliantly preserved, and this nice, quite large dorsal plate. So it's preserved, it's not complete as you can see, but it's preserved on this sandstone block. And you can see these kind of fingers of bone going off into the sandstone block just at the edge of the plate. Now, several aspects of the anatomy of this animal suggest that it was not fully grown at the time that it died. The neural arches are not fused in the dorsal vertebra that we have, and also we have a sacral centrum with an unfused neural arch. So my colleagues at the Museum of the Rockies decided to do some bone histology to examine the ontogenetic stage of this animal when it died. And we sectioned the tibia and the fibula. Unfortunately, these bones are preserved in a very iron-rich sandstone, which made it rather difficult. This histology wasn't great, and they had to grind the slides much thinner than you normally do. So these results aren't the best in the world. But generally what we're seeing in this animal is that we have a well-vascularized fibrolamellar bone, and we see that throughout the cortex. So we don't see any decrease in vascularity as we get towards the outside of the bone. And that means that the animal was still growing and growing at the same rate, so growing quite rapidly when it died. We see about 15 lines of arrested growth, or lags. This is where growth slowed, and these are usually interpreted to be annual or thereabouts. We see about 15 of those, although the inner cortex is remodeled, so there may well have been more. But crucially, we don't see an external fundamental system. So an external fundamental system is some closely packed lines of arrested growth that you see in adult specimens around the outside of the bone, when, and these indicate cessation of growth effectively. So the growth slowed to such a degree that you just get very, very closely packed lags. And that's usually histologically when you'd say this animal is now an adult individual, and we don't see this. So this bone histology, it really suggests that this animal was still growing and still growing quite rapidly when it died. Now, Cary and Jack, my co-authors, would actually have a heart attack if they saw this slide. But just for illustrative purposes, I've plotted up the humerus length against this kind of relative growth stage. This is what they'd have a heart attack about, because histology people don't like putting things into brackets like this. But just bear with me. The sort of relative growth stage that I'm talking about here is an animal that was still growing quite fast when it died. And the bone histology of Sophie, the NHM Stegosaurus, has been looked at as well. And it was also growing quite fast when it died, and there's no evidence of cessation of growth. So it looks like these two animals were roughly kind of a similar ontogenetic stage when they died, roughly-ish. However, the humerus of Sophie is quite noticeably larger than that of our own specimen. Now, a couple of previous studies have also done some bone histology on other stegosaurs, and particularly on these 3 specimens of Stegosaurus musi in this private museum in Switzerland. And what they found was that 2 of those growth had slowed, but there was no external fundamental system. So they were beginning to slow down, but were not what we would call fully histologically mature. And then the largest specimen up here has an external fundamental system, so is an adult. Also, this is a specimen of Stegosaurus stenops from the Denver Museum, and it's quite a large one, and that also had an external fundamental system. So what you can see here is that, admittedly, I don't have an enormous amount of data. But when one works on stegosaurs, you work with what you've got, and this is it, basically. So this is what we're working with. Obviously, we need to fill in some of these gaps, but it does appear that Stegosaurus stenops appears to be a larger species at adult size. And presumably, if we assume similar life history parameters, it actually grew faster to attain that adult size than our Stegosaurus musi individuals here. So it seems that Stegosaurus musi might well have been a smaller species of stegosaur. Now, I want to just move away from histology and anatomy and just talk about the Morrison Formation briefly, where these animals are found. So the Morrison Formation outcrops across the western interior of the USA. It's shown here in the blue polygons, or the Morrison outcrop. And it's where all your most famous dinosaurs are from. So Diplodocus, Stegosaurus, Allosaurus, everyone's favourite dinosaurs are from here. it was deposited over a time period of about 10 million years. And this means that although that it's really, really intensively sampled and we have loads of dinosaurs from there, the problem is that we really can't do too much interesting work in terms of faunal changes, because we don't understand whether faunal changes occurred through time or with latitude, because the Morrison Formation is entirely uncorrelated. So we don't have a really good idea of whether we're looking at latitudinal changes or temporal changes in different species. And I've been trying to address this problem over the last 4 years. So I've been using a variety of geologic techniques to build a chronostratigraphic framework for the Morrison, which I've now more or less done, although obviously it requires testing. This is it. I'm not really going to talk about it because I've talked about it loads before, and probably several people in this room are quite bored about hearing of it. But effectively, the point that I want to make here is that I was able to do this and determine that Stegosaurus stenops and Stegosaurus musi occur in the same time slices. So they were living at the same time within the Morrison Formation. So we're not seeing a change in species through time here. These are living side by side in the Morrison Formation. I downloaded data on Stegosaurus from the PBDB and plotted the occurrence data for determinate species of Stegosaurus. I also corrected this based on my own observations because the PBDB data is not always correct. Again, this is not a large sample size, I acknowledge that. But based on what we have right now, based on the available data, what you can see is that Stegosaurus musi occupies this area in Montana and Wyoming to the north, whereas Stegosaurus stenops occupies Utah, Colorado, and Wyoming, and the two sort of meet in the Bighorn Basin of Wyoming. Now, the Morrison in Montana is not anywhere near as well explored as the Morrison down in Utah, so it's possible that this is a sampling artifact and that Stegosaurus stenops was actually present across the whole basin. But in over 150 years of sampling the Morrison in Utah and Colorado, there are no individuals of Stegosaurus that have come from there. So again, you know, this is pretty tentative and it's not based on a lot of data, but it does seem like, based on the data that we have right now, that we have this northern smaller species of Stegosaurus and this southern larger species of Stegosaurus. Now this is an intriguing pattern because a variety of evidence from clay mineral sedimentology to general circulation modelling suggests that the south of the Morrison Basin was more arid than the north during the Upper Jurassic. And among extant mega herbivores, actually large size has been interpreted as an adaptation for aridity. And this is because a variety of physiological life processes scale to the 0.75 with body mass. So that means that large animals can get by on poorer quality food. They can walk further because they've got longer strides to get to different food sources. So it's kind of interesting that we have this large species that appears to be in the south and this smaller species in the north. So perhaps tentatively the pattern that we're seeing here is this large size in Stegosaurus stenops is actually an adaptation to the aridity in the southern parts of the Morrison Basin. This work was funded by a Geological Society grant, the Edward Garwood Fund, and I was supported by an Imperial College Research Fellowship during the course of this work. Just going to do a quick plug. Me and Paul are currently advertising for a PhD position on the evolution and paleobiology of thyrophran dinosaurs. It's fully funded. If you want to come and chat with me about that, please do. And thanks very much for listening.